Hello and welcome everybody, and welcome to our online attendees. I am very happy to see you all got settled with coffee and croissants. And please feel welcome to our 14th Innovation Cafe, where we will aim at medical tech in space tech in medical industry. We have quite a few speakers today, and I'm very happy to see every single one of them because the range of medical applications of really futuristic tech is astounding, and I'm thrilled to hear what the progress of us as a species is going to be. I'm very happy to say that we have a few colleagues joining remotely from our Köln Astronaut Center, where we have a medical team that might find some of these applications really interesting and possibly follow up on the contact or have very worthy comments. And I encourage everyone here in the room to also have a lively discussion and exchange contacts and network. So without further ado, let's get started. I don't know Enrico Brega, who's coming from DaXemGmbH, which is a startup company that developed something they named VireXbuster, I think. Did I say it right? Which is an antimicrobial coating that sort of prevents microbial buildup on surfaces. So without further ado, Enrico.
Yeah. So thank you very much for having here. So I'm Enrico Brega. I am the CEO of DaXem. I found very interesting the Medea presentation. You work from inside, we work from outside. So what is antimicrobial coatings? So this is it. We developed a technology that with the technology we have made that is a mix of molecules that are already known, they already have an history, but so that they are easy to register as biocide and there is no new danger to know because everyone, we think we know everything about this technology, molecules. And I just go to the next one. So this is the problem. We know that in space there is a lot of bacteria. Okay. And yeah, thanks. Especially, it's been a problem since the beginning of the exploration, the long time exploration, since the Russian near space already. There had a lot of mold flourishing around. And also, the discovery that survive very long the spacecraft, even if there are some kind of cleaning, especially in the Destiny module and the Harmony module of the ISS, International Space Station, have been found quite a lot of flora and fauna that you can see here in an example. And additionally, recently, there was a paper published in April, I believe, this year, about bacteria that mutated and in space. So the problem is that if we take down on Earth this mutated bacteria, we don't know really what happens. So the non-space problem, we can connect to the healthcare problems. So every year in Europe, 8.9 million of hospital-acquired infection happens. And we have, of cost, in US alone, the hospitals, they have $35 billion for hospital-acquired infections. And okay, we can disinfect, but solvents, they damage the polymer surface, and micro cracks can be formed. So, and the bacteria, they stay inside, and the virus and the mold, and it's very difficult to remove them. So this paper published from the Arizona University says that if we make a long-lasting disinfectant, 36% of the hospital-acquired infection can avoided. This is a huge number, very huge. One is not proceeding. Sorry, I have a problem, technical problem. I can go back, but I cannot go forward. Can you? Okay, thank you very much. So the traditional solution is disinfectants, but they are intensive annually, and they have to be applied every time, every day, and they are time consuming, and they evaporate and then create a VOC. Yeah, and so there is a lot of plastic bottles also that is not so ecological. So therefore, with the VireXbuster technology, we created an easy way that is the spray, and therefore that we also have an additive and a for bulk that this is for an additive for plastics that has to be still developed, and for this we need some funding. Can you please this next one, please? So how it works, this technology? So this little particle, 5 microns, they are inside the coatings, and some of them, they emerge statistically outside, and they enter in contact with the bacteria and inactivate the virus and the mold. If you want really to disinfect, then you have this, every time you disinfect, then you start again to have a development, disinfect, drop down, and then it start again the development. With VireXbuster spray, then we have this, it works continuously 24/7, so it's a big advantage. So we have made, we have certifications. So the Fraunhofer Institute tested it and is 99.9% effective against virus. Quality labs make the test on gram-positive, gram-negative. And also, we are very safe on the skin. We don't create any allergy because Dermatest made a test, and we are the only one that have excellent. Next, please. Okay, so current solution does not work very well. This is an example on the International Space Station, and there is all this mold developed. UV light is not a solution because not only is the problem for the eyes, but also it damaged polymers. It was already tested by Volvo, but they give up on UV light for disinfections because it damaged all their interiors. I've seen a solution was sponsored by the ESA with the UV lights to disinfect the inside of the AVI, the extravehicular equipment, but I don't believe it's really a solution because for the effect of UV light that is damaged. And also they need light to functions, or they are very expensive, or they are big component to be applied that are difficult, or they contain nanomaterials. That is not so good a solution because we don't really know what they will do on our body on the long term. Next. Okay, so we have, of course, we have competitors, but we can see that we are the only one that have all an high efficacy against bacteria, high efficacy against virus, and durability because we have about 12 months of durability. Chemically, and we are hypoallergenic, and we have a German biocide authorization. So applications, of course, we have the space applications. We're thinking to the Mars and the Moon bases. We're thinking to the space ESS, and but we have also many laboratories that use these solutions, because it helps to make a second layer of safety in their laboratories. And also, for example, inside the incubators that is with difficult part accessible, it's very useful. and of course the hospitals and anything else. Also, anti-legionella is also a solution inside air conditionings. Next one. Okay. So this is an example of applications. We use it in the airplane because it's more, we know more the data. We didn't have the data of space stations. So we can see that 30 times application of disinfection, it costs, and we compare it to 1 per month application of the VireXbuster. We see a 95% saving in cost, because the biggest part is the operator that has to make the applications, of course. In the International Space Station, I think daily they make cleanings inside, but of course, with something that costs 20 million per day of operation, to spend 1 hour of time of one astronaut for cleaning is not so convenient economically. Next one. Okay, so this is an article about us, published by an American magazine about infections. So they liked our product. Next, please. Next. Okay, and also this one, also that we are a recognized company as an advanced sterilization sector. Next one, please. So this is the conclusion. So what we need, of course, some co-founders, we need investors, we need also maybe a partner or customers to expand our customer list. And because we are a very important product that can help a lot of lives, and it's a product that it exists. It's here, ready to use. So that's all from my side. Thank you very much for the attention.
We have time for questions because that was short and sweet, to the point. Yeah. So any questions?
What happens to the carrier polymer after it expired and you have to reapply it? Do you put layer on top of layer, or do you take it off? Oh,
you can apply it layer over layer. Or you can also remove it if you want, because we made it that is removable with ethanol. You can remove it. We can do also a version that is not removable, but for the moment, it seems that this is the most appreciated solution. And one thing that I would like to say, I'd say about the micro cracks that are formed about the solvent. So this is a coating, so it added a surface above, and you get a new surface, and you close or you seal all the micro cracks. So you have also some mechanical benefits. And also, can I talk also more about, but I would be out of argument of the question.
Anyone else? Yep.
The coat have any flexibility after you apply? Because I imagine you are using, for example, in the aircraft, usually are under a lot of stress, mechanical stress, especially in the galleys. So the question is, have any flexibility during a time, or you need to apply after periodically times?
I've not understood if it's a problem of mechanical, so you made a deformation, or if it's a problem of
the cracking. So probably you have micro crackings in the galleys, usually because you put the coffee butters, blah blah blah. Yeah. So the thing is, you have any time horizons for supporting the?
Yeah. So technically, mechanically, chemically, 12 months. It works. It works a little bit more, but let's say that in average condition, 12 months. Okay, if it's a coating, so of course, mechanically, if you have, I don't know, the wheel drive of a car-sharing car, that for hours you touch it, there we recommend more once a month to make the recoating. But self 1 year I can stand. Of course, maybe you can say also inside a space station is not very good to make spray solvent-based solution. So we also have a non-spray solution, just to anticipate it.
That was exactly what I was about to ask. You stole my question. Thank you.
Yeah.
Yes, I was going to ask, how long does the 99.9% efficiency last? Is it over the duration of the whole month, or how long?
Okay, for the whole month, yes, we can say the 99.9%. After 1 year, we have 90.2% of efficacy, of residual efficacy, and then it's needed to apply to have a full. But 90% is already good. So I mean.
Do you already have any data concerning resistancy? Are there any germs resistant already against it? And how long does it take till they get resistant?
Okay. For this answer this question, we would need some investors because our laboratory is good, but not so good. And it's a what I can say is a multi-molecule. So the bacteria are attacked from different, with different mechanisms, very different. So the adaptation of the microbes and the virus is more difficult. So I guess that, this would answer your question.
But are there any known already who are already resistant against it?
No, not that we know, but more testing it need to be done, surely.
Okay, I have one more question. It might be silly, but if we spray a surface, can I lick it safely? And will it taste good?
I never tried. I tried on the skin to see directly to see the worst case effect, and nothing happened. We are not food contact totally. The component, yes, they are food contact, but the whole formula should be improved. So I would not suggest to put it in contact with food, water, drinkable water, and especially.
Thank you. That's what I was dreading.
Okay. Okay.
Thank you very much. So thank you very